and it can also update and query, so it can be said that for each transaction is composed of multiple agents. Each agent represents the process performed on a given transaction, on a given menu, and distributed system also has hardware impedance. The DBMS can be also run in different hardware impedance, only to complete the corresponding update operation. And for operating system, the DBMS set can run in different operating system environments need only complete the corresponding update operations. So, and finally, DBMS impedance independence achieve support. The ideal distributed system should provide DBMS independence. And for engineering development stage, the schema structure of a distributed database system has 6 levels. In this structure, the levels of the models at all levels are clear, and they can be summarize and explain the concept and structure of any distributed database system. First one is global external mode. They are user values for global application and are a subset of the global conception model. Secondly, global conceptual conceptual model. It defines the overall logical structure of data in distributed system. And the third one is the sharding model. Each global relationship can be divided into several disjoint parts, and each part is called a fragment. That is distributed data fragmentation. The sharding model is to define the fragment and the image that is global related to the fragment. And also the distributed distribution model. The fragments obtained by data sharding are still DDB global data and are logical parts of global relationship. Each fragment can be physically allocated to one or more different nodes in the network. The distribution pattern defines the storage nodes of the fragments. The image type of the distributed model determines whether the distributed database is redundant or non-redundant. According to the information provided by the distributed model, a global query can be decomposed into several subqueries. So, um, if there is a query that composes several subqueries for a centralized database, it can be a long recursion process that has lot pressure on CPU. So for a distributed system, a single composite query can be divided into subqueries and run in different nodes of the DBMS. So the mapping from the distributed model to each local database maps the global relation or fragments of local relationship stored in the local set to the local computation using the data supported by the local set DBMS. Both the sharding model and distribution model are global, so these models and corresponding images added to the distributed database system make the distributed database system transparent. And a global relationship is locally divided into one or more logical segments, and each local segment is located on one or more physical images. So, now I'd like to introduce about the engineer design of this system. The separation data of sharding and data distribution concept has formed the data distribution independent tag concept. The display control of database redundancy means the distribution of data in each set is clear at a glance in the distribution mode, which is convenient for system management. And how to achieve this consistency? We use CAP theory. The CAP theory was means that data consistency has to be equivalent to the latest version of data owned by all nodes, and the data is highly available, and also data has partition tolerance. Raft algorithm is also the way to achieve distributed data in a DBMS. As we know, when the problem is more complicated, it can be broken into several small problems to handle. Raft also uses the idea to divide and conquer. So the DBMS also have a log2 replication. The main function of log replication is to enforce the data consistency and high availability of the nodes. Security. Security is a security mechanism used to ensure that each node executes according to the same log sequence. Data consistency of data partition group. The data consistency of the data partition group is immediately consistent by default, so that it's only the master node is required to perform transaction operation to the considered as a successful operations. So the master node will synchronize the replication to the slave node in the future. Transaction log. If the difference between the LSN and master node and the slave node is 1, recall the master node will actively push the latest transaction log to the slave node. So how to replay from node logs? When the slave node gets the transaction log pushed by the master node, it will automatically parse the transaction log and replay. And when the slave node is doing concurrent playback, it is performed by the OID of the core and executed concurrently. That ensures operations on the same core will not cause inconsistency of data due to the concurrent playback. That's all. Thank you.